Video on Algebra Chapter 4, Section 3. We're going to talk about multiplying matrices. We've done adding and subtracting, and we've defined matrices in general. Before we actually do the multiplying of matrices, we have to figure out what you can and can't multiply with matrices. With matrices, the multiplying rules are a little bit more specific than in general. When you're multiplying matrices, the inner numbers of the dimensions must match. And so here's what I mean by saying the inner numbers must match. This first matrix here, this matrix right here, is a 1 by 2. This is a 1 by 2 matrix. This second matrix here is a 2 by 3. It's a 2 by 3 matrix. So if I want to do a 1 by 2 and multiply it with a 2 by 3, since the inner numbers out of these 1, 2, 3, 4 numbers, since the inner number of those four are the same, since these two match, I'm allowed to multiply them. If the inner two numbers don't match, you can't do it. So if I had like this matrix here, this is a 2 by 2, and this is a 1 by 3, I cannot multiply these because a 2 by 2 doesn't have an inner match with a 1 by 3. That cannot be done because the inner numbers don't match up. When the inner numbers do match, if the inner numbers match, the outer numbers tell you what the dimension of the new matrix will be. So here I've got the same matrix from before. I'm doing a 1 by 2 multiplied with a 2 by 3. Since the middle numbers match up, that means I'm good to go. But the outer numbers, 1 by 3, tell me that my new matrix will be a 1 by 3 matrix. I'll cover these 3 cells. The inner numbers tell you can multiply. The outer numbers tell you what the new matrix will be when you multiply. So again, before we actually do any multiplication, let's just figure out when we can and can't multiply. So if you want to pause the video and go through these 4 examples and figure out in advance if you can and can't multiply, that'd be a good idea. Just pause it now, and then when you're ready, go for it. This is a 3 by 3. This is a 2 by 3. The inner numbers do not match up. This one can't be done. This is a 2 by 2. This is a 2 by 3. This one can be multiplied, so when I multiply them, this tells me I can. So the outer numbers tell me that my new matrix will be a 2 by 3 matrix. This is a 1 by 3. This over here is a 3 by 1. I can multiply, my new matrix will be a 1 by 1, because these outer numbers are 1 and 1. And finally, this is a 3 by 1. This is a 1 by 3. The inner numbers match up, and that's a good thing, so it's going to give me a 3 by 3. Okay, so that's when you know if you can or can't multiply, and then what you're going to get. Here we'll work on the actual multiplying of the matrices. Remember, everything that you do with matrices goes row, column. Everything goes row, column. And this is going to seem very strange at first, but watch this video a few times if you need to. I'm going to take my highlighter, and you might want highlighters or colors when we do this. And first I'm going to do this row, that row 2, 1, negative 3, and I'm going to put it on to this column. This row here multiplies onto this column here. And what I do is I multiply the spots. So the top, this first number here, 2, multiplies the first number here, 6, and that becomes 2 times 6. Then I do 1 times 1, and then I do negative 3 times negative 6. And that right there is just going to occupy one cell in my new matrix. That's just one cell of my new matrix. Remember, this first matrix was a 2 by 3 And the second matrix, matrix B, was a 3 by 2. So it's going to become a 2 by 2 matrix. Well, this right here is the first top left cell of that 2 by 2 matrix. We'll leave that there for a second. Now I'm going to do this same top row. So I think I'll erase this. I'm going to do this same top row by the right column. Top row, right column, because everything goes row column. So I do 2 times 2, which is 4. Or not 2 times 2. Then I'll do 1 times 3, which is 3. Then I do negative 3 times negative 4, and that's positive 12. And all these things here, you're getting added. I actually did the multiplication already. Like I already said that negative 3 times negative 4 is positive 12, which you'll start doing. It's faster that way. And then those three things get added up. There's the top right cell. Next, I'm going to do the other row. I'm going to do this row here onto this column here. I don't know if I should change colors or not. I think I'll probably stick with the same ones. So I'm going to do 4 onto 6. 4 onto 6 is 24. 0 multiplied by 1 is 0. 5 multiplied by 6 is 30. Then I'll do my same row, this row here, onto the other column over here. Four times 2 is 8. 0 times 3 is 0. 5 times negative 4 is negative 20. Now I do the math and I add these up. This became 12 plus 1 is 13 plus 18, because negative 6 times negative 3 is 18. 12 plus 1 is 13 plus 18 is 31. 4 plus 3 is 7 plus 12 is 19. 24 plus 0 plus 30 is 54. 8 plus 0 minus 20 is negative 12. That is matrix multiplication. It's going to make your head hurt the first couple times you do it, but pretty soon you'll get pretty quick at it and get a feel that all you're really doing is multiplying and adding and multiplying and adding. And just the whole idea that, you know, this row here is kind of turning on to this column and then this column. That's the real idea, just to wrap your head around. So if you're good with that, you're probably good for this video. But I'll give you a chance to work on these 3 problems, then I'll do it myself, so you can pause it and then try them, and then we'll do one word problem. This is a 2 by 2. This is a 2 by 3. So my new matrix is going to be a 2 by 3. 2 by 3. So I'm matching up the outer numbers. What you might find really helpful is to actually build like a 2 by 3 matrix with 1, 2, 3, 1, 2, 3, and think about those slots. There's going to be slots here. This, for example, is the top left spot. So what I'm going to do is multiply the top row with the left column. Top row, left column, gives me top left. Whatever. So I do 6 times 3, which is 18. 2 times 2, which is 4. Do it again. 6 times 1 is 6. 2 times 5 is 10. Finally, 6 times 9 is 54. 2 times 7 is 14. I just did the top row to all 3 columns. Row, column, row, column, row, column. Now I'll do it with the bottom. I'll do bottom row, left column. Negative 4 times 3 is negative 12. 1 times 2 is 2. I'm going to eventually go faster, but I'll finish this one at this pace. Negative 4 times 1 is negative 4. 1 times 5 is 5. My arm is actually getting very, very tired. Negative 4 times 9 is negative 36. 1 times 7 is 7. Add these up. 22, 16, 68, negative 10, 1, negative 29. There is my multiply matrix. Okay, after a while you should be able to do this faster. This is a 2 by 2, this is a 2 by 2. I know that my new matrix is going to be a 2 by 2 because of these outer numbers. So I'm going to go row, column. This becomes 5 minus 8, which is negative 3. 2 plus 0, which is 2. 15 minus 16 is negative 1. 6 and 0 is 6. That one's done. Finally, I'll again do this faster. This is 5 plus 6, which is 11. I did 5 and then 6. I get tired of changing colors, but I guess I can probably stick with it. 5, 6 gives me 11. There's 10. And there's 8. 10 and 8 give me 18. Negative 4. And row to column, so negative 4 and 0 give me negative 4. And negative 8 and 0 give me negative 8. Finally, here's kind of the first example I'll show about where this can be useful. And matrices are absurdly useful. Okay, they're one of the most useful things we're going to learn. If lecture rooms cost $180 per night and standard rooms cost $65 per night, we've got this hotel scenario. Well, one way that we could calculate the cost that we're going to, or the income we'll make from these rooms, is I could take my cost and put it in a matrix. So here's 180 for Hotel A, and here's 65 for Hotel B. If I put that in a 1 by 2 matrix, I can multiply that by my 2 by 2 matrix, 6, 9, 18, 12. And when I multiply these, I'll end up doing row to column, and what that'll do is tell me how much money Hotel A made. That will give me all the income from Hotel A. So we do 6 times 180, 180 times 6, and 65 and 18. Change those colors again, 65 and 18. And whatever that comes out to, that's how much money Hotel A made. So I'll grab my calculator and actually calculate that real quick. Speaking of calculators, we'll learn how to do this on our calculators pretty soon. That comes out to $22.50. And I can also do, well, know I'm setting this up kind of poorly. This is going to come out to a 1 by 2 matrix. So here I've got 2250, and I'll do 180 times 9, 65 times 12, and that comes up to 2400. This is how much hotel A made, this is how much hotel B made. If I wanted to, I could add those up. I get 2650. And that's matrix multiplication. Have a wonderful day.